Alright, today in geometry we are working on lesson 1.3, points, lines, and planes. Our objective is to name, sorry about that typo, to name points, lines, segments, rays, planes, collinear points, and coplanar points. Lots to cover. Alright, here's our first set of vocab words. Geometry is what we're studying this year. A point is a specific location in space that has no size. It is represented by a dot. So, when you see it in a diagram, I'm just going to create some white space here to work in. When you see it in a diagram, it will just be that, a dot, named by a letter. When we name points, we usually just use the letter. So here is our diagram. This is how to name it. So in a diagram, you'll see it with a dot. When you talk about it or answer a question referring to a point, you just use the letter. Points are capital letters, just by convention. There's no rule that says that, but has to have a dot. In this class, you'll always see it with a capital letter. Okay, to show you a line and a line segment, I'm going to have to create a little bit of space up at the top. So I want to make sure we're all done with this number 1 geometry vocab word. If not, we can bring it back up later. But I just need a little space to draw. Alright, now that I have a little room to work, let's do our diagram and how to name a line. Our diagram is going to be what you might expect, a line, but it will have arrows on both ends. And it will have, or should hopefully have, at least 2 points somewhere on it. Not always, but usually we'll see at least 2 points on our lines. For this one, I'll call them A and B. Sometimes you might also see a lowercase italicized letter next to the line, like a little N. That's lowercase, usually italicized letter near the line. So there's our diagram for a line. When we talk about lines, when we're writing it out or referring to them, we name them using their points most frequently. So we need at least 2 points. Well, we only use 2 points when we name them, and we put a little line over the top of them. So this is how to name that line, line AB. That's one way. We've got 2 other ways we can do it. We can also name it line BA. We just need to use 2 points. It doesn't matter which order we go in, but we still put that little line above it. The third way that we name lines is using that lowercase italicized letter. But this way is just a little bit different. We actually write it out as line N. So sometimes you'll see them named by just that little lowercase letter. Okay, for number 4, line segment. It is very similar to a line, however, it has endpoints on both sides instead of arrows. So I'll name this one segment CD. So here is our diagram. Also, there's no little italicized lowercase letter by it, just the endpoints. To name it, we would do that similar to how we name lines. We use the 2 points. In this case, we're just going to put a bar over them, like a little line segment. No arrows. And again, we can reverse or switch the order of the letters. Either way works. Either way, we're naming the line segment CD. All right, our next definitions. We'll start with array. Array is basically a combination of a line and a segment. So on one side you have a point, on the other side of it you have an arrow. Usually you'll also see another point somewhere on there. This time let's call them L and M. Here's our diagram of array. When we go to name it, again it's similar to both a line and a segment. We use the 2 letters. We put a little ray over the top. The little ray over the top always points to the right, if you're curious, even though our diagram might not always point that way. The other important thing about naming array is that you can only start at the endpoint. So L has to be the first thing I write down. We cannot reverse the order on array. Start at the endpoint and then use another point closer to the arrow side. All right, let's talk about collinear and non-collinear points. Non-collinear means they are not on the same line. Collinear means that they are. So we'll start with non-collinear since that's number 6. For non-collinear points, we have to have, ooh, misspelled that. We have to have a couple lines. They can be touching, they could not be touching, whatever you really want them to be. Put a line there, and put a line here. This is just one instance that could be a diagram. I'll call that point X, and this one point Y. So there's a diagram. We could label this point too, if we wanted to. Z. That way we can use this diagram for collinear also. So we'll just add that up there. So you can use this diagram for both. So 2 points that would be non-collinear would be points X and Y. Right? So in the how to name box next to the diagram, you could say point X and point Y are non-collinear. And then for collinear, you have a couple options in this case, actually. You could say points X and Z are collinear. If you prefer to use points Z and Y instead of X and Z, that's fine. Y and Z are also collinear. Either way works for me. Alright, next we're going to talk about a plane, coplanar points and non-coplanar points. If you are watching the replay of the notes, I would suggest you pause it right now if you need the definition of a plane before it disappears off the page. Wow, words. Okay, like the definition stated, a plane is like a floor So our diagram of it usually looks like some sort of parallelogram, quadrilateral box shape. And technically it does extend on in all directions, so every now and then you'll see it with arrows coming out the top, the sides, and the bottom. A real life example, like it said, would be a floor, a ceiling, a wall, a chalkboard, what have you. And we need at least 3 non-collinear points to determine a plane. So here's point Q. Here's point R. Down here I'll put point S. So any 3 points really. When we name a plane, we can just call it plane QRS. Name it by 3 non-collinear points. And you could put those in any order you would like. But oftentimes on the diagram there will be a bold letter, usually in one of the corners of the diagram. So like, what's the letter I haven't used yet? H. Put like a bold H up in that corner. Usually it's much smaller than that. Mine's a little exaggerated so you can see it. So another way of naming it would be to call it plane H. Just one bold letter. Notice that the H does not have a point by it because H is not a point. We don't put a dot by it. So if you had a question about name a point in the plane, H would not be a possibility. Okay, we've got a new diagram to show both coplanar and non-coplanar points. You can imagine that this line here is poking through the plane. It pokes a little hole in it. When we talk about coplanar points, we're talking about points that are in the same plane. In this case, points A, B, and C are all coplanar. But as soon as we introduce D into that set, it's non-coplanar. A, B, and C are all on the same plane, but D is not in that plane. So we would put A, B, C, D are non-coplanar. As soon as you introduce one that is outside the plane, they are now non-coplanar. Down at the bottom, our last definition of the day, thank goodness, is a postulate, which is a statement that is accepted without proof. We will learn a couple postulates in just a minute. So we'll talk about those when we get there. But it's something that we don't really argue about. We don't explain why it's the case. We just accept that it's true. All right, we're skipping ahead in the notes a little bit to these postulates that we need to have down. The first postulate that we have in our notes is that exactly 2 points determine a line. So that means you need 2 points to create a line. The other postulate is that 3 non-collinear points determine exactly one plane. So you need 3 points that are not all on the same line to create a plane. Alright, on example 3, we are to name 3 points that are collinear. 3 points on the same line. Well, looking at this diagram, I've got a couple different lines drawn, but only one of them has 3 points on it. So I believe the three collinear points would be D, E, and F. Part B asks for 4 points that are coplanar. Well, I see my plane here. Kind of looks like a parallelogram. And inside of that plane, I see D, E, F, and G. So those 4 points are all coplanar. Part C asks for 3 points that are not collinear. I know through any 2 points I could draw a line. So we introduce that third point. It means that we could not put a line through all of them if they're not collinear. So we've got several options here. You could choose like G, E, and H. That would be a possibility. Those 3 points are not all on the same line. It is not the only possible answer on that one, but it works. Alright, on this example, the first thing we are asked to name would be 2 lines. In this diagram, we have several options of, first of all, the lines that we choose to name, because we have 3 different lines, and also how we name them. For example, if I want to use this line that's kind of on the top part of the diagram, I would have to call this line N, using that lowercase letter there. So I could say I have line N. If I wanted to use this next one that's kind of in that crease, I could call that line P. And then this third one over here, I could call it line M, or I could use that notation that we talked about earlier and call it something like line DE, right, using 2 points on that line. Lots and lots of options to name 2 lines for part A. For 2 planes, we don't have quite as many options because there are only 2 planes given here. I recommend using their bold letter names. So I would call one of them plane T, and the other one is plane S. Right? We look for those bold letters in the corners that do not have dots by them. Those name the planes. 3 collinear points. We only have one option. We see a line with 3 points on it. C, D, E. Done. 3 non-collinear points. Again, we go back to having lots of options. I'm pretty confident I could not draw a single line going through A, B, and C. Remember, when we say a line, we're talking about a straight line. You have other options there. I just like A, B, and C. 4 coplanar points. Again, really only one option. We see this bottom plane. We have 4 points in it. Those would be the 4 coplanar points. B, C, D, and E. And last but not least, we are looking for 2 coplanar lines. I'll go ahead and put that over here. Really, we can pick whichever line you want to start with and just go from there. So let's say I wanted to work with line M. Line M is in this bottom plane here. The other line that's in that plane is the one that's on both planes, line P. All right, number 5, can 2 points be non-collinear? In other words, can you have 2 points that you could not draw a line through? The answer is no. You can always draw a line between 2 points. Can 3 points be non-collinear? Is it possible to have 3 points that you can't draw a single line through? The answer there is yes, of course. Are there points on segment AB other than point A and point B? This is something we might not have hit on as much earlier. But on this segment AB, there are lots of other points in between A and B. We just did not draw them or mark them. So the answer is yes, there are other points there. We just did not mark them. But we can. Right? They're all over the place. So many points. Can collinear points be non-coplanar? So can points be on the same line but be in different planes? The answer is no. If they are on the same line, there is a plane that contains them at the same time. Can coplanar points, sorry, that's a typo there, points, be non-collinear? So if they're in the same plane, can they be on different lines? The answer there is yes. You can have lots of different lines in the same plane, so just because they're in the same plane does not mean they're on the same line. Last questions. And these are easy ones. We've talked about it a few times. How many points determine a line? 2. You need 2 points to create a line. How many points for a segment? Also 2. Array? Still 2. But a plane, it bumps up to 3.